Anyway, today I'm here to talk about PIPSpro, which is what we call our TG-142 solution. And basically, it automates the analysis of over 30 TG-142 recommended QA tasks. And that includes, let's see, my PowerPoint is taking a break. There we go. Sorry. The MV and KV imagers, both in 2D planar for both the EPID and the onboard imaging KV imaging system. Cone beam CT, we also perform cone beam QA. We do a number of different types of MLC QA tests, including the image-based tests as well as log file-based tests, and I'll touch on those in a bit as well. The STEREOTACTIC module, the automated Winston LUT. So basically, it'll give you your 3D couch shifts for your stereotactic accuracies, and I'll touch on that also. Radiation light field coincidence test also. Starshot analysis for gantry, collimator, and couch. And then we also have a IGRT, kind of a trending package within the system as well. So kind of jumping ahead a little bit now to the software. The nice thing about it, we've got a centralized or local capabilities for the database management. We have it's a single access point system manager, and I'll kind of touch on that as well. But the nice thing about PIPSpro, if you're a single facility with just one or two LINACs, or you're a very large enterprise operation that has a number of different facilities, it's a very scalable package. You can scale it for enterprise or for that single facility very, very easily, and use it as you see fit for those types of operations. It's a very easy department and user setup. It kind of steps you through. You see on the lower left there what we call our system manager, and there's the divisions, the departments, the users, LINACs, etc. And the divisions, if you have a large overarching group, say like a Genesis Care or a Texas Oncology, Vantage Care, things like that, where you may have a whole host of departments under you, you can set that division up, and then you can go next to set up those individual departments. The departments themselves can set themselves up. Users, we've got a number of different types of users they can set up as far as like security and availability of the software. So we have a higher end intro, it's what we call a super user, and that has access to be able to add and delete functions within the system manager. You can change your thresholds, add or take away LINAC specifics, things like that. So that, and then we also have more basic ones that just allow for the tests to do, but they cannot do any change of the data or manipulation of the system manager, things like that. It's available with Citrix server support for those enterprise-wide systems. So you can go set that up on a Citrix server and have access to the software from just about any location and allow you to kind of track across the whole enterprise as you see fit. The centralized database, again, gives you access for enterprise-wide results and trending. So you can take a look and see what your different facilities are actually, how they're actually doing their testing, their results, things like that, and then trending against each other. So you can kind of track and see how those are performing. And then we also set up baselines, and that gives you what we call quick selects, and I'll kind of touch on that in the software a little bit, but it gives you direct access to specific tests, so you don't have to kind of set things up each time. You can just grab a quick select and get right into the testing. Kind of touched on this a little bit, the LINACs and thresholds. To set up your LINAC, you can see there you have the machine ID, the department, the manufacturer of the LINAC, etc. Putting all that data in there, and those will storehouse in the database itself. On the right side, the thresholds. These are preset from Standard Imaging, utilizing the TG-142 recommended thresholds for the different tests, but they can be tightened or loosened as you see fit. But they are preset with the TG-142 recommendations. We also have a what we call a QA results dashboard. That's kind of your opening screen, and that kind of gives you an overview of your last analysis results for your different tests. As you can see here, they show the results in the green, yellow, red pass, caution, fail type situation. What test was done and when that test was last done. So that's your QA dashboard, and I'll kind of show you where that resides on the software when we get to it as well. So it gives you a very quick and easy review of when those last tests were done. Getting into the tests themselves, now we have our planar imaging, both the MV and KV. We've got our two different phantoms here. We've got the KV phantom on the left and the MV phantom kind of central there, sitting vertically. And they're very similar in scope as far as the targets and such. It's just obviously for KV and for the MV ranges, there's more shielding and a little more thickness in the MV phantom than the KV phantom. But basically, it's a single phantom image and a flood field. You get your planar results there, your resolution, your uniformity, your noise, and your contrast to noise, along with your resolution MTF curve. And basically, you see the phantom there. The software will automatically pick the regions of interest and analyze those automatically. And then with the flood field, automatically it selects not only the darkest position on the phantom, or I'm sorry, of the image, and the lightest position on the image, but also five spots across the phantom for that uniformity. So you not only get your contrast there, but you get your uniformity tests as well. And again, it's a test of spatial resolution, uniformity, contrast, and contrast to noise. The cone beam CT test, similarly, we've got uniformity and noise, Hounsfield constancy, geometric distortion, slice thickness, low contrast visibility, low contrast detectability. And this actually utilizes the phantom that is included with the LINAC themselves. So if you have a variant or an Electa LINAC with the cone beam capabilities, you will have either a 503 or a 504 phantom, depending on which manufacturer you have. And we actually analyze that phantom accordingly and give you color-coded results for not only an overview, as you can see in the bar layout here for each individual test, and then each individual result, again, being red, yellow, or blue or green for pass, caution, and fail. But then you can also dig in a little deeper to see the individual results for specific tests, like the geometric distortion here, the slice thickness, and kind of comparing those results also being green, yellow, or red. Got a couple types of leaf speed, MLC tests, including the leaf speed QA. And the nice thing about our leaf speed is it's a true leaf speed QA. We don't do an average across an open field. We actually look at each individual leaf and report the leaf speed loss of each individual leaf. So you can see here on the we do a leaf speed loss. We do not only step and shoot, but for IMRT, but we also do moving window IMRT as well. And the interesting thing, if you look at this test result here on the right, you'll see that these are showing the left bank and the right bank of the leaves, the MLCs, and you'll see the outer leaves here kind of showing more failure as compared to the center leaves. And typically that's kind of a typical result, just because you see in a lot of plans those outer leaves do not get used as much as the inner leaves, so there may be some sticking. There may be extra lubrication there that causes some sticking, or just some reasons for those outer leaves to be a little bit slower than the leaves that get used on a normal basis. So kind of gives you those quantitative results, gives you again the individual leaf speed loss for each leaf in a bank. And then you can also see here, right here, this is kind of what I call the 10 worst culprits. So they find the 10 worst results for the different MLC leafs in each bank and report on that accordingly. But in the software itself, you can actually hover over each leaf, and it will give you the individual leaf's loss in millimeters per second as well. So it's a very thorough quantitative test for true leaf speed. Again, it's not just your average across an open field and average leaf speed of loss of all the leaves, but it's actually individual. And then you also have a repeatability test as well that we offer. We also have image-based MLC tests, which include a multi-port, better known, typically known as a picket fence test. We also report leaf position accuracy for the individual leaves, and then we also do a leaf transmission test too that reports both interbank and inter-leaf leakage as well. Radiation light field coincidence. This test is performed with phantom we call the FC2, and the FC2 has embedded fiducials for a 10 by 10 field and a 15 by 15 field. And we report basically the software will you set the light field to the phantom, and either 15 by 15 or 10 by 10. And then you take your image, and the phantom image has these fiducials, and the software will actually localize on those fiducials, knowing where those fiducials are, and they should be as compared to the edge of the phantom and where the light field is set up. It will report that light field, radiation field coincidence difference in this kind of window here, showing you the radiation light field displacement, the radiation crosshair displacement for that center axis here, based on that central fiducial, and then your light field crosshair displacement as well. So everything is summarized and charted. And then the thing as well, when you do reports and you can trend everything, you can kind of take a look and see how things are maintaining, not only for this test, but for your MLC tests, for your KV imager, your MV imager tests, your cone beam. You can kind of track and report on all those directly as well. And my PowerPoint froze up again. Let's see. It always kind of seemed to hang. That's what's going on here. There we go. Sorry about that. Unaccounted for technical difficulties, I guess. But anyway, we also do star shot analysis, both for EPID, typically filmless, but there are a couple tests that require film, obviously. But we do collimator, gantry, and couch. There's a one-click analysis for the results. You just have to basically click on the center of the spokes. Doesn't have to be directly in the center. Anywhere in that general vicinity, the software will localize on all those spokes. And then, according to TG-142, it will look at the different rays of the star shot and give you a diameter of a circle that incorporates all the rays of the star shot. And obviously, the smaller that circle is, the better the results are, and that's all incorporated into the test results for comparing it for the TG-142 results and their recommendations. Stereotactic module, the SRS module. This is an automated Winston-Lutz test. One point of note for this is this is the only module that we offer kind of as a standalone for PIPSpro as well. Typically, if you get PIPSpro, you get everything that I've showed you so far, and additional tests that I'm gonna kind of touch on. But then we also have this SRS module, the automated Winston-Lutz, as a standalone that can be acquired and purchased as well, and does not include the imager test and the MLC test, things like that. It is just the automated Winston-Lutz test. But it can analyze both MLC or cone-based stereotactic systems. It will calculate those optimal 3D shifts based on numerous images from different angles, both gantry angles, couch angles, collimator angles, et cetera. And we have a kind of routine you can use, but you can kind of set those accordingly as well. You can see our setup here has 8 images, but you do not have to do all 8 images. Obviously, the more images, the better for accuracy, but you can do it with as little as 3 images. And it will it will find the beam center and the center of the ball marker and give you those automated calculated shifts for your 3D optimization. And you can utilize any number of different types of Winston-Lutz phantoms. It can be a pointer phantom like you see in the lower left. It can be a cube phantom. We offer a number of different phantoms, but it can be as simple as any kind of Winston-Lutz phantom that you have in-house as well. IGRT module. This is kind of just a library type of system where you would use something like our Mimi Phantom to get your 2D matching and your 3D matching for the cone beam, and you would manually enter the deviations on a daily basis, and then you can actually track and trend that over time. So it doesn't necessarily have any kind of calculation results in this test here itself, but it does give you reporting on the deviations from day to day for your different 2D, 2D, and 3D, 3D matching. So it's a very quick and easy review for that type of test. But I'm just going to kind of like I said, I want to jump into the software real quick. I'm not going to go through everything in detail, but I'll kind of touch on a few things. So as I mentioned, here's the QA dashboard. You can select and choose the different machines you might have. Right now I'm using a fictional Maple Hospital's TrueBeam. So I click on that and you'll see that up in this bar. So that's always showing your active LINAC. You can see my SI sales one. I've got a whole host of different equipment here that I can look at. But for this test, for this demo, I'm just going to use a TrueBeam. The file, here's my system manager here. And like I mentioned, this is kind of where you set things up. You set up your divisions. You can set up your individual departments. You can set up your individual users, again, with your different security levels. There's administrator and therapist and super user recall, things like that. So it gives you different types of security levels as far as what can be done within the software. LINAC setup, again, same, pretty self-explanatory. This is where you set up your various LINACs. Your threshold, same thing. As I mentioned, they're set up to TG-142 recommendations, but they can be tightened or loosened as you see fit. And then the phantoms themselves too. So nice thing, one thing about our phantoms, the KV phantom and the MV phantom that we for planar imaging, we actually calibrate them at the factory and we send them out with specific frequencies for each individual phantom, for each individual resolution. So depending on what your phantom is, it will give you specific numbers to enter here. So that's kind of the system manager there, just kind of to get things set up. I'm going to hide the dashboard, but then I can go to my different applications here. This is where you easily choose things. So I'm just going to show you Imager QA, and I'll show you. Here's my quick select I'd mentioned. So once you have a baseline set up, you can have these quick selects. I'm just going to show you the QC3, which is the MV Phantom. So I'm going to take a look at our AS1000 and see what we get there. So I'm going to load my images, and basically you set this up once and it will remember where your images are set. I grab my phantom image, my flood field image, open those up, and I can review my image. You'll see that the phantom, the software actually automatically found those points of interest noted by the blue circles, as well as the points of interest within the flood field itself. I can accept those. You can adjust those too if for some reason it's the first time doing it, or you feel that the points of interest are off. You can adjust those and edit those accordingly. But as I said, it automatically will find those spots of interest, those regions of interest on the phantom, It will go into the flood field, find that darkest spot, find that lightest spot for your contrast to noise. It will go and find five spots across that phantom for your uniformity and give you those results here. So you've got green is passing, yellow again, caution, red is failure. Get an MTF curve here so you can track on those. This one shows all of our resolution. You can pick and choose if you want to look at your F50, your F40, or your F30. Kind of shows you where those are located on that curve. So that's basically what you've got for either the KV or the MV imaging. Going to close that. And maybe I'll show you the cone beam, and then I'll show you maybe the STEREOTACTIC module as well. But quick select here. I want to do my CBCT for my CATFAN 504, which is the Varian system. Similarly, I'll find my phantom set here, my CT set here. There's 64 images in this particular CT set. I open that up, loads the phantom. It will automatically localize and find what we call the key slice. And once it runs through its analysis of that phantom, it will automatically give you those results. Here's your key slice, and it kind of keys on those 4 pins and that center bead. It's that center bead there. So that's what it's looking for as far as the key slice goes. Automatically kicks out the results for your uniformity noise, your Hounsfield constancy, spatial resolution, distortion, slice thickness, low contrast visibility, and detectability. I can click on any of these here, or I can go to this pull down menu here if I want to see any individual one. So if I want to look at the Hounsfield constancy, I can bring that slice up. It looks at these 8 different plugs in the phantom here, looks at what the expected Hounsfield unit is, for air, 1000, for polystyrene, 35, acrylic. So it gives you the expected, but then it also gives you those measured values as well and reports on those. So that's a very quick and easy check there. If I wanted to maybe take a look at my slice thickness, this one actually uses the same slice, but now instead of the plugs, we're using these step wedges that are built into this phantom module here. Again, gives you the slice thickness, your expected thickness of 2.5, and what those measured thicknesses are calculated for the bottom is 2.545, so within acceptance, and gives you that passing. You can also see the results here for low contrast visibility and the geometric distortion. So that's kind of a highlight of the cone beam tests. And one last one I just want to kind of touch on would be the log file based MLC tests. So I can load up my trajectory files for Varian as you know, and you have a number of different things. You can actually look at individual true plans, like you have a prostate plan or a right neck arc plan for modulated arc. But you can also look at just a straight leaf speed. So if I want to look at a leaf speed here, complex, and I'll kind of show you what I mean by complex. So you can see here we have the representation of the MLCs. A basic one would move all the leaves in unison together in one speed at one time. The complex actually, and I'll show you, I'll play it. You can kind of see what it does. It just moves every other leaf. It'll go a certain distance and stop. Then it'll move the second bank or the every other leaf accordingly there, and kind of run through. So that's what we call a complex. But I can go ahead and I can calculate on that. It'll run through, and there's my calculated results here. Again, showing you individual leaf speed for the left bank B or the A bank. I can click on, or I just hover over any of the leaves, and it will actually show me. So here, for example, leaf 50 is a loss of 1.36 millimeters per second. So that's kind of showing you what you're seeing there. So that's kind of a highlight of the leaf speed. And again, I can't emphasize this enough. We actually are one of the only companies that look at each individual leaf speed. We don't do an average of the field. Some other systems out there will just look at the overall average of all the leaves and just report a single number for an average leaf speed loss. We actually report on each individual leaf speed, which is somewhat unique. And if you'd like, at the end I'll show you I'll give you my email address. We have a white paper kind of explaining the advantage of the individual leaf analysis versus that average. So I can be happy to share that with you if you feel to like you'd want to take a look at that, and I'll be happy to send that white paper to you. But that's kind of what I want to touch on, as far as the software goes. So just kind of give you a little bit of an idea of the navigation through it, things like that. Like I said, we've got the imager QA, which is the MV and KV and the cone beam. We've got the radiation light field. We've got the star shot, which is the gantry couch and collimator. We've got the STEREOTACTIC QA module, being the automated Winston-Lutz test. We've got that IGRT kind of databasing for your daily checks and trending. And then we've got the image-based and the log file-based MLC QA as well. That image-based being the picket fence and the leaf transmission and leaf position, and then those log file-based like I just showed you here for the actual leaf speed loss. I just want to kind of jump back into couple last slides, and then I'll let you go. I know I've had you about a half hour now, so I don't want to keep you too much longer. But one thing we also have, we have a software package available. It's a cloud-based package called QA Pilot, and that's our QA management software. So that's a software that you can utilize for scheduling and kind of maintaining all your QA results in one spot. Be it your TG-142 or your TG-51, your different like a daily test. So if you're using something like our Beam Checker Plus, you can automatically upload your daily results for constancy, flatness, and symmetry to our QA Pilot software as well. But we released PIPSpro version 5.7 late last year, I guess it was. And with that, we incorporated what we call a QA Pilot portal. And it looks very similar to in some respect to that dashboard I showed you, but you can actually pick and choose what tests you want to directly put into and upload into QA Pilot. So when you pick those tests accordingly, you can then have those right in QA Pilot. So then it's kind of a storehouse of all your QA results. So like I had mentioned for TG-51, for TG-142, again your daily QA, things like that, and you can kind of manage that, and you can review all those. You can easily get those up to administration for reporting. If they're doing any kind of auditing or accreditation, you'll have all that at your fingertips using our QA Pilot software. And if anybody's interested in QA Pilot, we can certainly set up a demonstration for that, or just keep an eye on our website for the webinars, because we do schedule webinars for QA Pilot as well. Shows you again, there's a longitudinal data for the results for our cone beam, some of our cone beam stuff. So it gives you all that uploaded information to QA Pilot automatically. So just kind of touch on some of the advantages. We provide, everything is quantifiable and repeatable results within PIPSpro. Makes your center very easy. It gives you direct capabilities to become compliant with TG-142. It's a centralized database, so it's scalable to all your specific needs. Again, if you're only a single facility with 1 or 2 LINACs, all the way up to those very large multi-LINAC systems out in the field as well. The results dashboard at your fingertips for a single view of all your most recent results. Again, everything is quantifiable and all our phantoms, our precision phantoms, built specifically for PIPSpro. Very intuitive user interface for each component. You saw me just kind of very quickly navigate a few of the tests, and you can kind of see how easy and quick that is. Everything's right at your fingertips, as well as the automated and automatic calculations for those results right at your fingertips. It's a very smart software, so all the field edges and fiducials and things like that are typically automatically registered and found. So that leads to less mouse clicks. So it's a much quicker overall software to use. And again, like I mentioned, there's over 30 TG-142 tests in this single package of PIPSpro. So as I mentioned, if you wanted to get a little more information, I kind of went through things quickly today. If you want to see things a little more in depth, feel free to go right to standardimaging.com and you can inquire there directly. You can also email sales@standardimaging.com, and we can schedule a more in-depth overview of PIPSpro with your regional representative, and we'll be happy to set that up at your convenience. Also, if I did mention, if you want, my email address is hpetersen, it's Petersen @standardimaging.com, hpetersen@standardimaging.com. So if you wanted to get a copy of that white paper on our leaf speed, individual leaf speed analysis, please feel free to email me as well.